So I wasn't going to make this video. There's a lot better YouTubers like Sonic Audio, where I picked up most of my information from, and I can see why he doesn't like these jack sockets. They're horrible. This one here has gone dry jointed, and because there's so many problems, and this has the classic heat problem from the drop down resistors, which make the plus and minus 15 volt rail. This trace, I'm scared, is going to become detached from the board because the glue will sort of weaken over time. And here are the 5 watt resistors that they mounted right on top of the fiberglass. So you can see how that over a lot of time has discoloured this fiberglass and caused lots of dry joints pretty much everywhere on the board. Let's get the microscope out. This is the foot switch socket. This is the input, which actually isn't moving but poorly soldered, and some more dry joints here. This is that trace I want to reinforce, going directly to a dry joint there. And this is what you get when you crudely make a plus and minus 15 volts from a higher voltage rail. There's a lot of power dissipation from those resistors. This is the top of the resistors, and these are the bottom. Yeah, shocking really, and they never sorted this out. So luckily, just changing the caps, and these F&T have a really nice gauge wire, so I'm going to use these to reinforce the solder traces. Look how much gap they've left there. There's really no need for that to be so close. And even one of these pads is disintegrated. So I used a fiberglass pencil to scrape off the silt screen. That will give us a really nice base to solder onto. I'll put a lot of flux on there. And I've just rested the arms I cut off and the caps just in place, ready to solder. And I hooped the wire around the legs to make a great contact. So we'll just make sure we haven't shorted this connection out. These ones here are also quite tight. There's no need for that to be tight, but other than that, that looks much better, and that thick gauge wire will help dissipate as much heat as possible. And that's what it looks like, not through the microscope. I'm quite pleased with that. This amp originally came in with the fault of screeching, but I wanted to get this up to at least some sort of spec. Remember to put that cable tie in. So I know you amp guys love your F&T caps. Remounted some new resistors off the board now, so hopefully that should cure any more heat problems. I'll leave a link to the original video I made diagnosing this amp, but by the advice of Dr. Daniel Pratt, we decided that we were going to go for this nice set on Watford valves, and it uses this low power valve in the phase inverter, which is meant to give it more headroom, so it'd be very interesting to see how this sounds. I've just screwed everything back in, and I've realised this input socket, the main input, is not right. I thought it was just a bigger part, but actually once you got it out, it just looks like it's been soldered in lower, and the threads obviously have been chewed because it's in the wrong position. If you look at this angle, You can see there's barely any threads left. Okay, I managed to unsolder it, and I've managed to solder it at the right height. And without a washer, I can actually get the nut on, and it's secure. And let's just check the value of these resistors. 160 degrees. But it works. Okay, no screeching. That's good. And my OCD got the better of me. That's better. And just for the record, I'm setting the bias at a very factory 62 millivolts. Seems to be working fine. Well, that was well worth doing all the preventative stuff. It seems to have fixed everything. And I'm using another nut because we use this one here. I should have probably swapped the input sockets around as input one is normally used. But anyway, we'll see how long this lasts, and catch you next time.